Here's an idea. Since everybody's talking about renewable energy, why doesn't someone find a way to capture the wind? Yes, we have turbines, but you know, the wind doesn't always blow when we need it the most. Hey, it's just an idea. Xcel Energy and the U.S. Department of Energy's National Renewable Energy Lab, or NREL, have teamed up to do just that. They are exploring ways to capture the wind's energy and deliver it more reliably than Mother Nature. Not that Mother Nature's done anything wrong, but wind is naturally, well, windy, gusty, variable. So while it's one of the least expensive renewable energy sources, it's also rather unreliable. Xcel Energy and NREL are testing ways to convert wind energy to hydrogen, which is an energy carrier that can be stored. Then, when energy demand is high, we can use that hydrogen, reducing our need for other energy sources, such as natural gas, oil, and coal. So how does it work? First, let's talk about hydrogen. Why are we converting wind energy to hydrogen? Hydrogen is the simplest and most abundant element in the universe, but it's almost always found as a compound with other elements. It's an energy carrier, much like electricity, but it's not a primary source of energy like wind. To use hydrogen, we must extract it from compounds and, until now, that extraction produced greenhouse gases. For example, most hydrogen is reformed from natural gas or other fossil fuels by stripping the hydrogen atoms out, creating greenhouse gas emissions in the process. Or hydrogen can be produced by splitting water molecules through electrolysis using sources of electricity, such as fossil fuels, which themselves generate air emissions. Our entire wind-to-hydrogen process is green because we are using wind power to run the emissions-free electrolyzers and then use that green hydrogen to make green electricity when we need it. Basically, this project has the potential to use our least expensive renewable energy source, wind, and convert it using a green process, electrolysis, into storable energy, hydrogen, that we can tap on demand. Now that you understand why we like hydrogen, let's take a look at some of the main technologies and concepts that we are testing. There are several steps in this conversion process. We are testing not only the system that's transforming the energy, but also each technical component along the way. Before we discuss the entire process, let's look at some of the individual technologies. We are testing 2 variable speed wind turbines that create energy from the wind. One is a 100 kilowatt turbine and the other is a 10 kilowatt turbine. 2 proton exchange membrane electrolyzers and 1 alkaline electrolyzer that can produce hydrogen gas from water. Metal storage tanks that store hydrogen for later use, and an internal combustion engine that runs on the stored hydrogen, generating electricity that can be sent onto the grid during peak demand. Essentially, this project studies how we can capture the energy contained in the wind, convert it into a form that can be stored, hydrogen, and then convert it back to electricity during times when it is needed most to run our homes, our businesses, and someday our cars. Let's go back and look at some of the questions we hope to answer. We are testing those 2 turbines, experimenting with the different energies that they produce and how to get that electricity into the electrolyzers, where it can be converted into hydrogen. At the heart of this challenge is the fact that most turbines create AC, or alternating current electricity, while the electrolyzers require direct current, or DC. Here's what we're doing about that. The 100 kilowatt turbine. This turbine already has onboard electronics that take the wind's varying AC electricity and turn it into 750 to 800 volt DC. Normally, this DC electricity has to be converted to AC current like we use in our homes. But we're going to skip that step and just use it straight from the turbine, with one exception. In order to be used in our electrolyzers and ultimately converted into hydrogen, we have to step that 800 volts down to 50 to 100 volts DC. The 10 kilowatt turbine. This smaller wind turbine does not have onboard converters, so its wild AC must be converted to DC before it can be turned into hydrogen by the electrolyzers. We designed and built new integrated wind-to-electrolyzer electronics to get the wind-produced electricity to the electrolyzers more efficiently. Now we have the wind's energy delivered in a useful form to the electrolyzer. An electrolyzer has one main goal: to take in water and electricity and produce hydrogen and oxygen. We are testing 2 types of electrolyzers to compare their performance. 2 Hogen 40RE proton exchange membrane electrolyzers from Proton Energy Systems, and 1 Teledyne HMXT100 alkaline electrolyzer. Now, the hydrogen from the electrolyzers must be compressed so that it can be stored in tanks. Like air compressors found in mechanics workshops, our system compresses the hydrogen gas that's coming out of the electrolyzers from 150 pounds per square inch to a maximum pressure of 3,500 pounds per square inch. The higher pressure allows more hydrogen to be stored in the tanks. The stored hydrogen will run an internal combustion engine, generating electricity that we'll send onto the grid. We'll run the engine between the hours of 4 and 7 p.m., coinciding with one of Xcel Energy's daily peak energy periods. This step can also be accomplished by using a hydrogen fuel cell. Thus, we have taken the variable nature of wind, captured it, and used it when our customers need it most. The hydrogen can be used today to power internal combustion engine vehicles that run on hydrogen gas, and eventually to power fuel cell vehicles, which will start coming on the market in the next decade. Imagine cars with no greenhouse gas emissions, only water. Of course, we are very excited about the possibilities offered by this study. Xcel Energy and NREL are learning how to isolate hydrogen without creating greenhouse gases, creating several uses for and improvements on wind and hydrogen energies, comparing electrolyzer technologies, reducing energy loss between wind turbines and electrolyzers, exploring a way to provide consistent support of the grid using renewable energy. We hope to have these systems running and providing us with new data throughout 2007 and 2008. Hydrogen technologies have the potential to reduce our nation's dependence on foreign oil, improve air quality, and help the United States to maintain its economic competitiveness. With this project, the National Renewable Energy Laboratory and Xcel Energy are exhibiting technological leadership with a unique spirit of teamwork that will explore a potentially practical, safe solution to meet our country's energy needs.